All right, I want to go ahead and start talking through this bell work. Number one, I want to solve this algebraically. If you decide to go the route of expanding the binomial and then trying to factor it, it's not going to work. This does not factor. So if I can't factor it and I can't graph it, what could I do with it? Solve it. Walk me through. Add 24 to both sides. When we say we're solving it algebraically, we're going to follow order of operations backwards. Each step undoing what we can see and what we can get to around the x. So the first thing I'm looking at is there any addition or subtraction over on the side where x is? Notice about this, though, that I can't touch things inside parentheses until all the way up here. So I can add 24 to both sides, but I can't touch that minus 4 inside. All right, so that would give me 3 times x minus 4 squared equals 24. Is there any other addition or subtraction that we can get to? Gentlemen, I need eyes up here, please. Is there anything else that we can undo with addition or subtraction? Nope. All right, then I'm going to move on to my next step. Is there anything that I could get rid of using either multiplication or division? We can divide by 3. So I'm going to divide both sides by 3. What is 24 divided by 3? 8. So I have x minus 4 squared equals 8. Is there anything else that we can get rid of using multiplication or division? Nope. So then I'm going to move on to exponents. Do we have any? Yeah. The squared. How do we get rid of that? Square root. So I'm going to square root both sides. Over on the left, the squared and the square root cancel each other out, which just leaves me with what? X minus 4 plus or minus the square root of 8. Is the square root of 8 a whole number? No. That's why we cannot solve this by factoring. If we got to this stage right here, and it was something like 9 or 16 or 25, then we could have factored it. That's what it means when this comes out to be a whole number that's nice and pretty. How do I get the x all by itself now? Add 4 on both sides. And so I get that x is equal to 4 plus or minus radical 8. How many answers do we have? 2. I want to find both of them. We're going to do x equals 4 plus radical 8. We're going to get one answer. And then we're also going to do x equals 4 minus radical 8. And that's going to give us our second answer. I want them as decimals, not as reduced radicals. If you put this into one of my yellow calculators, it will give you a reduced radical answer. If you're using one of my yellow calculators, like on the test next week, and you want a decimal answer but it won't give it to you, right above the enter key, there's another white key with arrows that point left and right. That's the button you want to press if it's not giving you a decimal and you want a decimal. So after you get the answer and it gives you reduced radical, you would press the arrows. When I do 4 plus radical 8, what do I get? That was for the plus? No. 4 plus radical 8.
What do you want, 100?
At least 2 places after the decimal. Yes. 6.828. Or you could round that to 6.83. That is the approximate location of one of the x-intercepts. The exact location is this. But that's hard for me to know where that is on the graph. So I'm going to change it into decimal form. Sorry, thank you. What about when we subtract?
$1.7.
1.715, right? It came out as a positive. So here it is in decimal form. This is the exact location of it. 1.17 is about where I'm going to find it on the x-axis. So far, so good? All right, please let me know if you guys have questions about this, because being able to solve algebraically from this form is one of those skills that we're working on developing. What is the quadratic formula?
X is equal to negative b plus or minus square root b squared minus 4 times a in 4a times c over all over 2 times a.
Yes. And when we say all over, why is it all over 2a?
Because you don't want to leave out the minus.
Yes. Remember yesterday when we were building up to this point where we developed quadratic formula, we derived it. Negative b over 2a, that's our axis of symmetry. That's the x part of the vertex. This part of it over here, the reason that we're plussing and minusing is that's how far left and right we're going to go from the vertex to find those x-intercepts. Yes, sir?
Can you give me a calculator?
Absolutely.
Thank you.
You're welcome. All right, number 3, we wanted to solve using quadratic formula. When we substitute into quadratic formula, you only plug numbers in. We're not worried about the x's. So I want to know a, b, and c, and this needs to be coming from standard form.
You can. What do you want us to change into standard form first?
Yes.
You can add 8 to the other side.
Absolutely. Your b value is not negative 8. It's positive 8. You have to get it into standard form first, which means it has to be equal to 0 first. So 2x squared plus 8x plus 4 equals 0. What are the values for a, b, and c?
2, 8, and 4.
2, 8, and 4. So that's what we're going to substitute in. Whenever I substitute into quadratic formula, I always put parentheses around the things that I'm substituting, because that saves you from making mistakes later on. So I have x equals
Negative 8.
negative, and then we're going to plug in the 8,
Plus or minus.
plus or minus.
Square root. 8 squared.
8 squared
Minus 4.
minus 4
Parentheses 2. Parentheses 4. And then over 2. Parentheses 2.
over 2, and then inside parentheses 2. We're going to clean this up just a little bit, and then we're going to pop it in the calculator.
Do you have to do that, or can you just put it?
Well, based on some other questions that I might ask, you want to simplify at least this part of it right here. So let's look underneath the radical. I'm going to pull this off to the side, and we're going to simplify just that part. So I have 8 squared minus 4 times 2 times 4. What's 8 squared? 64 minus 4 times 2 times 4. When we multiply things, we can only multiply 2 things at a time. So I'm going to do that here. What's 4 times 2?
8.
So I have 64 minus 8 times 4. What is 8 times 4?
Wait,
So I have 64 minus 32. What is 64 minus 32? 32. This is what's going to go underneath the radical. So I have x equals negative, and then 8 is just negative 8, right?
You want us to simplify the denominator?
Yep. What is 2 times 2? 4. This is what I would use to put into my calculator. We're going to put it in twice, once with a plus and once with a minus, to get our decimal approximations.
Will you take out 4s if we don't do that? Like,
If you don't do what?
if we don't simplify it?
Well, hold on. I'll get to why it's important, okay? Let's do the subtraction one first. What do you get when you do negative 8 minus radical 32 over 4? Negative 8 minus radical 32 all over 4.
You get negative.
3.414. I'll help you with putting it in. Show me what you got. Hit this button right here now. There you go. All right, now what about when you add? Yes. Negative 0.5. I need the last two numbers from you. 86. Beautiful. Okay. So I want to take just a minute to talk about this. And Tristan, this gets to your question here. We got how many answers? 2, because we added something and then we subtracted that same thing to get our other answer, right? What about if when we had simplified the part underneath the radical, that's called the discriminant, by the way. This piece over here, all that junk is called the discriminant. If we had simplified the discriminant and I'd gotten a 0, what's the square root of 0? 0. And so that's telling me I would move to the right 0 units. How far am I going if I go to the right 0 units? 0. I'm not moving, right? What about if it's go to the left 0 units? Still not moving. So how many roots would I have? 1 root, because I still have the negative 8 over 4 part. That's my axis of symmetry. And that is touching the x-axis if it has this plus 0 and minus 0 with it. That means the vertex is my one and only root. If we get a positive number underneath, we're going to add something and subtract something. So we would have 2 answers. What about if I get a negative underneath the radical? You can't do the square root of a negative. All right. This is on page 107, by the way. You might want to jot this down real quick up on those upper lines. If b squared minus 4ac is a positive number, we will add and subtract and get 2 answers. If b squared minus 4ac is 0, do we move? No. We don't add or subtract anything. And we get 1 root. And that 1 root would be negative b over 2a. If b squared minus 4ac is negative, You cannot square root a negative number. Not possible. No real roots. We do have a way of talking about square roots for negative numbers, but that is imaginary numbers, and that is beyond the scope of this class. In Algebra 2, you guys talked about imaginary numbers, but we're not digging into that. As far as we are concerned, the only thing we care about is actual x-intercepts. So Tristan, this is what you would be able to determine by simplifying that part first. You could look at that number at the end and say, oh, I know I'm going to get 2 answers in the end. Or I know I'm not going to have any real answers in the end. Or I'm going to just have 1. Okay? That type of thing makes a really good multiple choice question. Just saying.
Which one?
How many roots does it have if the discriminant is 5 or 4 or -2 or 0? I would say, how many x-intercepts does it have if you do b squared minus 4ac and you simplify that and you get this? Oh, there we go. Okay. Real quick, page 108, and then I've got something for you guys to do for the remainder of the class period. Page 108, so just flip the page. Yep. I'm not a huge fan of where exactly they decided to put these little speech bubbles. And I really wanted to have time to fill in this page yesterday, but we ran out of time on the clock. Because we had built this whole quadratic formula from completing the square. And I want to make sure that we understand where all the parts are coming from. The speech bubble down at the bottom looks to me like it's pointing to our axis of symmetry. Do you remember what part of the quadratic formula tells us this? Not b squared. Negative b over 2a. And then I think this speech bubble is supposed to be pointing to this root right here. That's negative b over 2a. And how do we find the one on the right? Would you add or subtract if you wanted to move to the right? You would add plus the square root of b squared minus 4ac all over 2a. How would we find the root that's on the left? Same as this one, but with subtraction sign. This is the speech bubble that I like their placement of the least. I felt like it needed to be over further. X equals negative b over 2a, because that finds the middle. And then we would subtract the square root of b squared minus 4ac over 2a. I'm going to go ahead and label it. You guys don't need to label it up here, but what the parts of quadratic formula tell us. Okay. Remainder of the class period, and this is how you get your participation points for the day. There is a quizzes that I want you guys to complete. I'll put the code up on the board. You're going to go to joinmyquiz.com. What is this one doing again? That is the axis of symmetry. That is the x part of the vertex. There we go. That finds the exact middle because we know that all parabolas are symmetric, right? Left side and right side are the same. If you fold it in half, they lay on top of each other. So I find the middle, and then we figure out how far left and right we need to go. Tristan, do you have a question? Okay. So quizzes, joinmyquiz.com. The code is 17389749. Counts for participation. Technically, it says they're timed questions. Don't worry, it's like 5 minutes per question. It's more than enough time. I want you to practice using quadratic formula. Practice using quadratic formula. I want you to participate, so use it for practice. All right. All right. Let me go back here in case anybody needed to snap a picture of this. The code, if you need the code. Let me figure out what that is. If you need the code again, 17389749.
We're practicing quadratic.
Joinmyquiz.com. There we go. Joinmyquiz.com. 17389749 gets you in.
We're practicing quadratic equations.
You're practicing with quadratic formula. Yes. So you don't need to rederive the whole formula. We did that yesterday. It took us all day.
Right.
Now it's just practicing using it. But deriving it means that we understand where these pieces are coming from and why it works the way it works.